So I think we did KP questions as well. Now what we're going to try and do is, okay, we're going to start off with acids and bases. So the first, now the first thing about it's about acids and bases is what's the definition of an acid? What's an acid?
I don't remember the definition.
It's a proton donor. Proton
Oh,
is,
okay.
so it's a proton donor. Vice versa, a base is a proton acceptor.
I thought you meant like a full definition. That's why I was. It's just a bit confused.
That's it. That's the definition. That's it.
Okay.
So a proton donor, a proton acceptor. So it's basically an acid is a molecule. It could be any molecule that that releases H+O ions. So if there's someone who's giving off H+O ions, so that's what an acid is, and vice versa. A base is a base is going to be accepting. So it's going to be any molecule that gains H+O ions. As I said, it's going to be gaining H positive ions. Now the thing is that you've got acids and bases. The next question is why are acids and bases important? Okay, what's the significance of acids and bases? Okay, why are they important? Why do we study them? Was there any idea?
It's because they're involved in chemical reactions.
They are involved in chemical reactions, but the reason why they're important is that water is important. And when you have water, let's say there's water, everything on planet Earth, all chemistry involves around water. Okay? Why is water important for chemistry on this planet? Well, what's the reason for that? Well, why do we keep drinking water? What's the reason for that?
Because it's a good solvent.
Okay, so
Can dissolve.
it's basically the medium in which it's a solvent, right? Water, we absolutely don't do anything to water. Okay? Water is completely useless for us, but we have to drink it all the time, and the reason for that is that it's the main medium, it's the main solvent in which chemical reactions happen. So if there's one particle over here and there's another particle on the other side, if there is water, they would be able to move around. They would be able to move around. They would be able to reach each other, and they would collide with each other. So, I mean, the way if I breathe in oxygen, the reason oxygen goes to my cells is that there's water in my blood, and that carries it to other parts of my body. So that's why water is important. Otherwise, water doesn't really do anything. Okay? Is that clear?
Yep, it's clear.
Plus, if you remove water, no chemistry would happen. Okay? The reason why you don't see chemical reactions happening in a desert is that particles cannot move on their own. They need a medium in which they are able to float around. So you don't see anything happening on the moon because there is no water there, right? So the reason you have so much chemistry happening on planet Earth is that 70% of the Earth's crust is basically water, right? Now, the thing with water is that it's not just water. Water tends to break down. Some of these water molecules over here, for example, this one over here, would break down and it would produce two ions. One of them is going to be H plus 1, the other one is going to be OH minus 1. Is that clear? So,
Yeah, it's clear.
so some of your water molecules would ionize and they would ionize very weakly and they would produce H plus 1 and OH ions, right? Normally, they would produce H plus 1 and OH ions in equal quantity. So, normally, what's going to happen is that if you have water, let's say another water molecule breaks down, and another set of H plus 1 and OH ion gets produced. So, normally, what would happen is that the concentration of H plus 1 ions and the concentration of OH ions is going to be equal. Now, this is known as a neutral solution. And this is known as pH 7. Is that clear? You clear it? Yes or no? Can you hear me?
Sorry, I couldn't hear you. Could you say that? Could you repeat what you said?
TNA, I was saying that normally what's going to happen is then water breaks down and produces H plus 1 and OH ions. It's going to produce an equal amount of H plus 1 and OH ions, right? Is that clear?
Yeah, that's clear.
So when your solution has an equal amount of H plus 1 and OH ion, that's known as a neutral solution. That's known as pH 7. Okay. I said, then what if I add a molecule of an acid to it? Then what will happen? Which ion would be greater in quantity then?
The H plus ions.
Okay, so if you add acid to it, let's say this purple molecule is an acid. So what is it going to do? It's going to increase the quantity of H plus ions, right? So you're going to have more H plus ions because it's going to produce H plus ions, right? So in that case, what's going to happen is that the concentration of H plus ions would become greater than the concentration of, and this would be known as an acidic solution, and you're going to call it the pH is now less than 7. And similarly, if you add a base to it, what a base would do is that it would accept H plus ions. So the quantity of H plus ions in solution would decrease. Or vice versa, you can say that the quantity of OH ions would increase. You're going to have a bit more, a lot more OH ions, TK. So in a basic solution, this is what a base does, that it increases the OH ions. That's going to be your and you're going to say that the pH is greater than 7 in this case, TK. Is this clear?
Yep, it's clear.
TK, and you've got a pH scale. On this pH scale, you got you got pH neutral somewhere in the middle. And let's say this is 14, this is pH 7. So you pH 0. If the pH, we're going to talk about what pH is later on. So if you move in that direction, that's going to make things alkaline or basic. Just similarly, if you move in the other direction, so that's going to make things acidic. Okay, so middle part would be that the concentration of H+1 is equal to the concentration of OH ions. Right part would be that the concentration of H+1 is going to be quite less compared to the concentration of, and left part would be that the concentration of H+1 would be greater than the concentration of OH ions. Okay, is this clear?
Yep, it's clear.
अच्छा अब ये कि so acid is a proton donor, base is a proton acceptor. So remember that. So we're going to do a question. We're going to do some questions now, okay? Related to so this definition of an acid and a base is known as a Brostad-Lowry acid-base definition. So don't get confused if this term is ever used. That's just the name. That's just the name of the definition. Acid and bases have like three definitions. There's an Arrhenius definition. In an Arrhenius definition, it's an acid is a proton donor. A base is the one that produces OH ions. And then there's a Lewis acid base definition, which is an acid is a a I think it's a lone pair. So your base is a lone pair donor, and acid is a lone pair acceptor. ठीक है, but we are going to stick with the H+1 definition. ठीक है, is this clear?
Yep, it's clear.
अच्छा तो कहाँ पे एक second. Let's do a worksheet on acids and bases. अच्छा, there's going to be here, for example, this one. So you're seeing that ethanoic acid is a stronger acid in liquid ammonia than in aqueous solution. So ethanoic acid, right? Now ethanoic acid produces H+1 ions. So it's going to lose this H+1 ion. He's saying that it's a stronger acid in liquid ammonia. So when it's with ammonia, it's able to lose the H+1 more. And but not with water. It's not going to be a strong acid with water. So what does that mean? Which statement is correct?
Is it D?
Firstly, is ammonia um so firstly that's wrong because water is more polar. Because water, the oxygen is more electronegative. Is that clear? Compared to
Oh
nitrogen.
yeah. Yeah, that's true. Okay.
So why is ethanoic acid behaving as a stronger acid with ammonia than with water?
Um, is it B?
It's going to be A. Because remember, an acid and a base, they work together. Okay, always remember, like if I do this reaction over here, I've got ethanoic acid, right? An acid is always going to be with a base. One of them is donating a proton. So there's somebody who's accepting a proton, right? Now, the acid is going to lose an H plus ion. So when it loses, so when it loses an H plus ion, what's going to happen to it? It's going to turn into CH3, CO minus 1 ion, right? And what will happen to ammonia? It's going to gain an H plus 1 and it will become NH4 plus 1. Is that clear?
Yep, it's clear.
So if you look at the equation, this is behaving as an acid. This is behaving as a base. This is the one that is a proton donor. And this is the one that's a proton
So
acceptor.
does the acid donate the proton to the base?
That's always going to happen because if there's an acid that produces H plus 1, then there must be something that would be accepting H plus 1, right?
Yep.
So
Okay.
they always work together. Now the question is that he says the same thing happens with water, right? Do you know the structure of ammonium ions? Like, what's the structure of ammonium ions?
Tetrahedral.
And why does ammonia accept an H plus 1 ion? Because it's got a lone pair, and those lone pairs are going to datively attract H plus 1 ions. Is that clear?
Yep.
So now with water, you're going to have the same thing that you got ethanoic acid. You got water. Ethanoic acid is going to do the exact same thing. It's going to become CH3CO minus 1. And water is going to accept an H plus 1 ion. It's going to become H3O plus 1. And this water would also look like this, that there's a water molecule. And the water molecule is going to attract an H plus 1 because it's got lone pairs, two of them actually. And it will become H3O plus 1, okay? Is that clear?
Yep, that's clear. But how does this show that it's a stronger base?
Actually, I'm going to come to that point. As again, so ethanoic acid is basically behaving as an acid, and this is behaving as a base, right? Now he said that ethanoic acid behaves as a stronger acid when it's with ammonia, right? So why is ethanoic acid able to lose H plus 1 ions? Because the other one is strongly accepting the H plus 1 ions. Is that clear?
Yep.
So remember this point that when you have a strong acid, it will always be with a strong base. Even though technically, even if it's not a strong base, it's going to convert it into a strong base, because if you've got a strong acid which is readily losing H plus ions, the other one has to accept those H plus ions. So it's going to behave as a strong base. Is that clear?
Yep, it's clear.
So vice versa, a weak acid will always be with a weak base. Like if an acid is not willing to lose H plus ions and it's not producing H plus ions, that means The base is not getting any H plus ions. It's always going to be with a weak base. अच्छा, next है कि so that's one concept, right? Then there's first thing. So then there's another concept which is a conjugate acid and a conjugate base. Conjugate acid is that if you look or think about the reaction, these reactions are always reversible. So the other way, they can all also happen in the they can also happen in the backward direction. So they can also happen. One second. They can you hear me?
Yep, I can hear you.
So they can also happen in the backward direction. Now when they happen in the backward direction, then it's this one is going to be your base, and this one is going to be your, think about it in the backward direction. Now this one, if it goes back, it accepts H plus ions, right? Is that clear?
Yep.
So it accepts H plus ions. And if NH4 plus 1 goes back, then it what does it do? It loses H plus ions, right? You can clearly see that there's more H on that side, less H on the fewer H on the left side, right? अच्छा ये हो गया. So, but in the reverse direction, this is known as the conjugate base, and this is known as the conjugate acid. Same thing over here. I think this one is behaving as the base, and that one over here is the conjugate acid. Is that clear?
Yep, it's clear.
ठीक है. So, अच्छा, no, every acid will have a conjugate base. And vice versa. तो ये ऊपर ही देखो ना, like if I've got ethanoic acid, right? Ethanoic acid had ethanoate ions. That was the conjugate. So this one was your acid. This is your conjugate base. Is that clear? Like if you look over here, ethanoic acid, this is your conjugate base. Is that clear?
Yep, it's clear.
You got ammonia. So on the other side, you got ammonium ions. So ammonia is your base. Ammonium ions are your conjugate. Ammonium ions are your conjugate acid. So they always exist in pairs. Another point about this is that if you've got a weak acid, its conjugate base is going to be strong. And vice versa, no matter what the combination is, you got a weak base, its conjugate acid will be strong. Achha, what that means is that, let's say ethanoic acid is a very weak acid, right? Is that clear? Hello, Bertha, can you hear me?
Yep.
Achha, so about this concept. Achha, let's assume that your ethanoic acid is a very weak acid. Now it's going to have its pair, it's going to have its conjugate base, which is going to be CH3CO -1, right? So the conjugate base might be a very strong conjugate base. That's the reason why it's not ionizing. The way it makes sense is that look at ethanoic acid. If it's a weak acid, that means it doesn't like to lose H+ ions, right? Is that clear?
Yep, that's clear.
So that means if it loses H+ ions, then it will quickly gain those H+ ions back again. It doesn't like to lose H+ ions. So that means the base would be very, very strong. Is that clear?
Yep.
Okay. And vice versa, if you've got a strong acid, for example, like look at HCl. Its conjugate base would be just Cl ions. That would be the conjugate base. So if this is strong, okay, we wrote down that it's strong, then this must be very weak. That means if HCl likes to lose H+ ions, so it strongly likes to lose H+. So that means it doesn't like to gain those back. That means the Cl ions that are formed, they don't like to gain those H+ ions. That's the reason why HCl is losing H+ ions in the first place, right? Is that clear?
Yep, it's clear.
Okay, so just remember that you got acid-base pairs in every reaction. Okay, an acid will always have a base. A strong acid will always have a strong acid. A weak acid will always have a weak acid. Okay, the reason is, so a weak acid will always have a weak base. A strong acid will always have a strong base. And the reason I told you was that you got a strong acid, then the base will automatically be strong as well. If this loses H+1, the other one also gains H+1. So they're going to behave in quite similar ways. Then I told you about pairs, that you got an acid, it's going to have a conjugate base. You got a base, it's going to have a conjugate acid. And then I told you that they're opposites. You got a weak acid, the base is strong. You got a weak, strong acid, that means the conjugate base is weak. Okay? Is that clear? Is that clear?
Yep, it's clear.
Okay, so let's continue tomorrow then. Okay? We'll just do questions now.
Okay.
That's pretty much it. Okay? That's all about acids, just acids and bases. So we'll do questions tomorrow. Okay?
Okay.
Okay, then take care, Vata.
Okay. Thank you. Allah Hafiz.